Okay, just a few things. I promise I won't take too long, but I kind of want to go through a little bit of what this chapter entails and why we do some of the things we do um, quickly, and then I'll turn you guys loose to work on your quizzes and assignments, exercises, whatever the heck they're called for this class. So a few things, some of these again are pretty basic principles, things that you should have had probably in high school math when we talk about mean, median, mode, those types of things, right? But then we get into a few other things that are maybe a little bit more complicated. A weighted mean, not too difficult. Geometric mean, that's probably not one that you've really had a lot of experience with. I might do a little quick example of what that is and why we might be interested in that. Range variance and standard deviation. Get used to especially standard deviation. Okay, variance is the square of standard deviation. The other way to put that is standard deviation is the square root of the variance, right? So knowing one, you kind of know the other without too many difficulties. But those, you're going to use standard deviation quite a bit in this class. Okay, so we'll talk a little bit about what that means, why it might be important when we look at data and those types of things. So away we go. We'll even look at Chebyshev's theorem. I have no idea if I'm pronouncing that correctly, but we'll see. So again, mean, right? Average. Average and mean mean the same thing, pretty simple. Again, I think I showed you guys, if not, I will. Real simple ways of calculating the mean using Excel. Arithmetic mean, yep. Click through some of those. We divide those when we talk about statistics. Oftentimes we're going to have the population mean. I got to remember what some of these sound like. Mu, yeah. So you'll hear me talking when you listen to the videos. You'll hear me talking about mu. That's what that one is, which means the population mean versus a cruise on here. The sample mean, right? Which is the bar x bar, I guess it's called. If I was reading it like a brand, I think that would be bar x, but I guess it's not a brand. So. And sample means it's really calculated the same way as population mean. It's just that we're doing it over a smaller sample size versus the whole thing, right? Median, that's just the midpoint. That means that half the values lie above that, half the values lie below that. That's all that means. But median can be very, very, very useful. Oftentimes you'll have statistics, let's say net worth of individuals. You know, if you got Jeff Bezos and Bill Gates and Warren Buffett and a few of those guys thrown into the mix, the average is going to be skewed up, right? So a median sometimes might be a more valid number that you would look at, to try to determine what most normal people have, let's talk about salaries or income, net worth. Most normal people have it above that or below that. Gives you kind of that midpoint, which is kind of nice. Again, you just take it's the one that's in the middle. Sometimes you got to calculate that because if you have an even number of data, then you're going to have to calculate what that is. Mode is the one that appears most frequently. Again, that's popular. Maybe if you're, what brand, I think that's what they're using here. What car brand is the most popular? Those types of things show up. We don't use mode a lot besides that, but kind of walks you through here what the relative positions of those might be depending. Weighted mean, why would that be important? Well, let's say you compared California, which has 30 million people, and Montana, which has 1 million people, and you wanted to calculate what the average unemployment rate was. Well, if California's was 10 and ours was 5, does that mean the average unemployment rate's 7.5? No, because California is going to have a huge weight, right? Because they've got 30 million people and we've got 1 million people. And so you use the weighted mean to calculate what the actual mean might be between those two states, okay, if you combined them. And again, the formula looks kind of daunting, but it wouldn't be that difficult, okay? In the example that I gave you, I think you just take California unemployment rate times whatever the percent of California's population would be, which would be 90 some percent, 99 point some probably. No, it'd be about 97, sorry. Somewhere in that neighborhood, times whatever their unemployment rate plus Montana's 1 million or 3% times our unemployment rate, and then calculate what it would be. Geometric mean. And geometric mean is something that's important mainly when we're talking about like rates of return, okay? I use geometric mean a lot if I wanted to figure out what an average annual rate of return might be on a stock market investment, say, okay? So if it earns 3% one year, 6% the next year, 5% the next year, 4% the next year, you can't just use the average, okay, because those rates are compounding, okay? And so the geometric mean gives you the effect of the compounding on that. I don't think that's what they're saying here, but it gives you the effect of that compounding over time, which is an extremely important thing if you really want to calculate that. That's one that I'll show you a little example of here in just a bit. So the geometric mean, again, this looks pretty daunting. You take the fourth root, you know, of your numbers to determine what your rate of return might be in that case, okay? That looks a little bit daunting. It's really not that difficult. I'll show you some ways in Excel that we can do square roots, fourth roots, those types of things. Dispersion just tells you where things are at, and sometimes we get some skews and whatnot, but it also, we're talking about range in this case, and then we are talking about standard deviation and variance. So the variance, and it even shows you here, right? The variance is the square of the standard deviation, or put another way, the standard deviation is the square root of the variance. So once you get the variance, you take the square root. Once you get the standard deviation, you take the square if you want to get the variance. You're going to come up with the variance first when you do the calculations. Range, pretty simple, okay? Standard deviation is not all that difficult. Population variance and population standard deviations aren't that difficult, really. They look more difficult than they are. Remember, this little deal here is the sum of whatever that is, a backwards 3, backwards or kind of an E type of a thing, whatever you want to call that. But that just means the sum of. So what do you get when you're figuring out the variance, right? You've got a list of data. You figure out a mean for that data. They got a total. And then you figure out what the difference is from the mean, okay, for each individual statistics. That's what this is. They don't show you the mean here. They should, okay? The mean would, if this is looks like it's a 29. Yeah, the mean's 29 there. I can tell just by, okay. So you figure out what the difference is, okay. Then you square it, okay. And then you calculate that, and you calculate the mean of that. That gives you the variance, and then you take the square root of that to get the standard deviation. It looks pretty difficult, but it's not that tough. The sample mean is you divide it by n minus 1. So instead of taking it divided by the n or finding the perfect average like you would with population, when you're talking about a sample, you take 1 off what your n is. Remember, n is the number of variables that are in your group of data. So if you got a sample of 20, then n minus 1 is 19, right? Sample standard deviation just gives you the formula. Those look pretty daunting. Chebyshev's theorem, I'm going to show you something that probably will make some more sense than actually reading this and trying to understand what it means. And I think when I show you that, it'll simplify it quite a bit. Really what it's telling you here is that in a normal curve, Again, I'll show you something here in a little bit. In a normal curve, okay, you got a data range, and based on the standard deviations, okay, how many data are going to fall within the standard deviations of plus or minus 2, say, plus or minus 1.5. It's fair. It's very consistent. It is consistent. Okay, it's absolute. Okay, and I'll show you a little deal that kind of make a little more sense maybe. Here's the empirical rule basically, and this kind of has to do with Chebyshev's deal, right? So this just gives you some data. The standard deviation here is 10, okay? So it's telling you that 68, or about 2/3 of all data, falls between plus or minus 1 standard deviation, okay? Plus or minus. 95% fall plus or minus 2 standard deviations, and nearly 100% fall between 3 standard deviations, okay, plus or minus 3 standard deviations. We do a lot with this, okay, so get used to seeing the curve, okay, get used to kind of messing with it, but I'll show you a better way to kind of mess with it. So compute the mean and deviate, okay. Again, this is to help you figure out the, to get grouped data. When you got a frequency like this, you know, if we did that, 200 up 600, and you wanted to figure out what the mean is of that, okay, you got to figure in the midpoints of all of these and do some addition and whatnot. You guys will do that. And the frequency, okay. So you got your midpoint, right? It's halfway in between. Your frequency was from the prior, you know. Multiply it gives you that. And then you divide that total by your total number of frequencies here. Yep. So the mean profit per vehicle in that case, not a bad example. Standard deviation, that looks pretty complicated, doesn't it? Okay, get used to it. There's easier ways to do it, but you're going to need to do it this way probably several times and kind of get used to this. Once you kind of get it down, it's not that big of a deal. So again, we got frequency. In this case, they've got a midpoint. So the F times the M, or the frequency times the midpoint, gives you that. Okay. Then you plus or minus from what the average was, which is what we calculated before, right? I'm sorry. Yeah, that should be right. Okay. Square that, gives you that. You end up down here, you get a variance. And then you take the square root of that variance, and it gives you, this is a sample one, it gives you what the standard deviation is, 652.33. So that means that there's on average, you know, the profit from each of their vehicles on average is $652 different from what the mean is, okay? Let me give you another example. I had my doc here a while back. She said, you know, you need to track your blood pressure every day. So every day I had to take my blood pressure morning and night, let it up. I called her up and I said, okay, my average is 130 on the systolic, about 80 on the diastolic, right? And she didn't ask this, but for me it was kind of important. She didn't ask, well, what's the standard deviation of that, okay? If my standard deviation was 5, that wouldn't be a big deal at all, right? That just means that on both the systolic, say, and the diastolic, that just means that periodically my blood pressure is a little higher, a little bit lower. But if I was to say that my standard deviation was 30, that would be a little bit scary. That would mean that at times my blood pressure might be up about 160 on the systolic, and on average, actually, that means it's probably going to be above that lots of times too. Okay, so that standard deviation gives you an idea how, you know, if your data's going like this on a line or just like that. And that's a very important calculation that we use, and for different things and different reasons, it's extremely important. Okay, so there we go. Now let me bring up Excel and kind of show you a couple things, if I can here. Oops, I'm going to do this that way I can kind of remember what it was I was going to tell you here, hopefully. Okay, the little box is kind of a pain, but here we go. So, if I want to do the mean of something, let's do, because I'm going to do this a little later. Let's say I got some interest rates. I'm entering them in instead of as percentages, 0.04 would be 4%, right? I'm just going to enter in some 0.08, 0.05. Oops. Screwed up there. Gosh, I'm really screwing up. Sorry. Got fat fingers. That's the problem. 0.08 again. 0.07. 0.06. 0.02. Okay. I always like to put an underline under that. Sorry. It's just a. If I want to figure out the average of that, I can just come here, right? This is where I want my output to be. I hit this. You guys are probably familiar with that. I hit average. It actually sees those, and so it's circling them. I hit enter, and now I know what my average is, 5.833%. Pretty simple, right? The other way to do that is to say, hey, I want to do equals, or you don't have to do that. You could do this. You could say, I want to do the sum. Come here. Sum of these numbers, right? I'm going to hit enter, and then I'm going to come back up. Click on there. I can hit divided by. How many deals do I have? 1, 2, 3, 4, 5, 6. Should give me the exact same number, right? Okay, a couple different ways to calculate average. Pretty simple. But how about the geometric mean? And why do I do the geometric mean? I'm getting a little bit ahead of myself here. But if I copy, and I hope you guys, again, I do some of these shortcuts here and try to show you, but if I want to copy this whole set of data, I can highlight it. That little black X appears down here in the corner where that square is. If I left click on that and hold it, I can just drag that over to the next series there. So I've got the same data there. I want to calculate the geometric mean. I want you guys to get used to coming up this insert function. It's really kind of nice. I go to statistical, and I'm looking for geometric mean. Do you suppose I'd be so lucky that it's going to have one that says geo mean, geometric mean, right? Lucky me. Okay. In this case, it brings it up like this. It says D3 through D8, and that's what I want, but I can also highlight that if I want to. Make sure, right? Hit OK. See how that's different? Let me make that bigger. So here's my average of that data. Here's my geometric mean, okay, which means on a compounded basis, if I was getting those kinds of returns, that would be my average compounded annual rate of return for that particular set of data, which is really kind of important. So, okay. I will tell you, and you guys, again, you're probably going to have to figure out standard deviations the long way, but you could do this as a check. Okay, if I wanted to come here and say, what's the standard deviation of that group of numbers, I can come up here again, statistical. You don't suppose I'd get lucky. Look at that. Standard deviation for both a population, standard deviation for a sample. Going to be a little bit different. I'll hit the population in this case. Asks me what numbers. I could do either one of these because they're the same, right? But I'll just highlight that data. 0.02, right, is my standard deviation. So again, you could do that as a check. I think that they're probably going to make you do that the longer form in some cases. It's kind of nice to know how the long form works anyhow if you had to. Let's see if there were any others. Oh, you think you can do mean and mode the same way? Yeah, they don't show up here, but they're going to show up here, right? So if I wanted to know, I'm getting this kind of busy up here, but you know, if I wanted to know the mean for sure, it doesn't show mean, so I probably have to do modes a little bit weird. It's kind of neat. That could be under arithmetic. Let me just see. They're not always under the right one. Nope. So let's go back to statistical. Average, right? Average is the same as mean, so that's probably why they have that there. Median is here. Oops. I want it to be these numbers. Highlight those. Boom. There's my median. They had to calculate it, right, because I had 6. So half of them above 6 and half below. And you'd be able to do the same with mode. In this case, I don't, well, I would do have a mode. My mode is 0.08, right? Because it appears twice. None of the others appear more than once, so. Okay. Give you some hints, give you some ideas on some things you can do in Excel there to work on this. I'll turn you loose now and let you work on those problems. If you have any questions, holler.